present the yellow fever vaccine's fractional dose trial. In 2016, yellow fever outbreaks affected several districts of Angola and the Democratic Republic of Congo, including the two capital cities. By the end of June 2016, the International Coordination Group on Vaccine Provision, or ICG, this is the group in charge of the supply of yellow fever vaccines during major outbreaks, had depleted its usual stock twice. At that time, around 18 million people had been vaccinated in the two countries. However, the outbreak was ongoing and there were a further 12 million people in need of vaccination. In this situation of vaccine shortage, WHO recommended the use of fractional doses. This decision was primarily based on a dose-finding study conducted by Biomanguinhos in Brazil, where lower than the recommended doses were found to be immunogenic. It's important to note that yellow fever vaccines often contain potencies above the minimum specification, given still the possibility to administer doses above the minimum with reduced doses. Following this recommendation, over 7 million people in the capital of DRC were vaccinated preemptively with 1/5 of the standard dose. In order to broaden and simplify the fractional dose recommendations, WHO called for research. The aim was to gather data on the applicability of fractional doses for the 4 WHO pre-qualified yellow fever vaccines and on the immunogenicity of fractional doses in children and HIV and symptomatic infection, as well on data on safety of the reduced doses. Following this, Epicentre and MSF, in partnership with the Oxford University and the Kenyan Medical Research Institute, and in coordination with WHO and yellow fever experts, proposed a trial to generate the data needed to recommend fractional doses for any of the 4 WHO pre-qualified yellow fever vaccines to be used in emergency situations when there are insufficient standard doses to protect the population at risk. The objective of our trial was to evaluate the non-inferiority in seroconversion of a fractional versus a full dose of each manufacturer, evaluated independently 28 days post-vaccination in an adult population. Assuming that 95% of vaccinees get protected after 1 dose, we defined a non-inferiority margin of 10%. This means that we will consider fractional doses non-inferior if less than 85% of participants vaccinated with a fractional dose got protected. As secondary objectives, we defined other immunogenicity outcomes, included the comparison of protection 10 days after vaccination. This is when we consider that most vaccinees get protected, and 1 year after vaccination. Safety outcomes included the assessment of adverse events up to 28 days post-vaccination. The trial included sub-studies in children and HIV-infected adults with 1 dose with one of the vaccines selected from the adult study. This presentation will focus on the results from the adult study. We designed a double-blinded, randomized trial to be implemented in Kenya and Uganda. Based on a pragmatic decision, we defined a fractional dose as 1/5 of a standard dose, corresponding to a volume of 0.1 ml to be administered subcutaneously. The trial included the 4 WHO pre-qualified vaccines. A vaccine batch from each manufacturer was selected with as close as possible potency to the minimum release for each manufacturer. The batches were evaluated independently at the National Institute for Biological Standards and Control. The selection of the batches close to the minimum release will allow for the applicability of the results to future batches. The trial includes 4 independent groups corresponding to the 4 manufacturers and 2 arms per group corresponding to the fractional and the standard dose. The trial was approved by several ethics committees and the regulatory authorities in the implementation country. A data and safety monitoring board and a scientific committee were constituted specifically for the trial to follow up the implementation and provide recommendations. Based on a 90% power and one-sided 2.5% significant test to detect the 10% non-inferiority margin, we recruited 960 adults in the 2 sites. The trial targeted adults less than 60 years of age who provided informed consent to participate, were not pregnant or breastfeeding, and had no contraindications to vaccination. also included people that had not previously vaccinated and had no history of yellow fever infection. At each visit, a blood sample was taken and serum sent to the Institut Pasteur Dakar for the PRNT analysis. The plaque reduction neutralization test is a method for the quantification of the neutralizing antibodies and the reference method for assessing immune response to yellow fever vaccination. Recruitment started in November 2017 and was completed in February 2018. In total, 1,029 participants were screened and 960 included, with 120 randomized to each arm of the trial. Over 96% of participants completed the study at the 1-year follow-up post-vaccination in each arm of the study. Immunogenicity results are now available for baseline and the 28-day follow-up. This is corresponding to the main objective of the study, protection 28 days after vaccination. As the data of the study is not yet complete, partial blinding continues, and we are not aware of which group corresponds to each manufacturer. Overall, the mean age of participants was 36 years of age, and 55% were females, without significant differences in the study arms by vaccine manufacturer. Seroconversion for yellow fever is well defined, and there is a specific antibody titer that is considered protective. Amongst participants seronegative at baseline, seroconversion rates were high in each arm, with at least 98% protected in each arm. The difference between fractional and full dose is represented in the figure, with the mean difference and the 95% confidence interval. None of the vaccines reached the non-inferiority margin, set up at -10% and represented by the dotted line in the figure. Geometric mean titers 28 days post-vaccination weren't elevated in all study arms, and fractional doses were non-inferior for the four manufacturers, with less than two-fold difference between the fractional and the standard dose. Considering that a titer of 10 is protective, all arms show a significant increase in titers from baseline, and the differences between the arms are not clinically significant. These figures show the distribution of titers by vaccine dose and manufacturer at 28 days post-vaccination, with the graph on the left of each figure showing the fractional dose. Each bar represents the percentage of participants that reach the specific titer, with dark colors showing the lowest titers. For each manufacturer, we can see that the distribution follows a similar pattern. Regarding safety, adverse events were frequent, with around 40% of participants reporting at least one adverse event classified as related to the study vaccine in each arm. The most frequent were headache, fatigue, muscle pain, and self-reported fever, and most were classified as mild. We did not find differences in the frequency and severity of adverse events by vaccine dose. During the 1-year follow-up, there were 9 serious adverse events, and none were related to the study vaccine. Our trial shows that fractional dose of yellow fever vaccine meets the non-inferiority criteria for the 4 WHO pre-qualified vaccines and is able to mount an adequate immune response in a high percentage of vaccinated 28 days post-vaccination. We selected batches as close as possible to the minimum content in virus for each manufacturer. Consequently, unless there is a change in this minimum, our results are applicable to future batches. We did not find any safety concerns regarding the use of fractional doses. Now it's important to establish the rapidity of protection and make sure that reduced doses do not cause any delays in the immune response, and that most vaccinees are protected 10 days after vaccination. Data on long-term protection is also needed to establish the need of revaccination in order to keep population immunity and avoid future outbreaks. The analysis of the 10 days and 1 year post-vaccination data samples is ongoing at the Institut Pasteur Dakar. Sub-studies in HIV-infected adults and children are at present ongoing in Kenya and Uganda using the Chumakov vaccine. I'd like to thank the study participants, the EDSMB, and scientific committee members. Thank you all.